Hello everyone, this is a video tutorial on method overloading versus method overriding in Java. First of all, let me point out that both overloading and overriding are examples of polymorphism in Java, and they're both used to implement methods with like names but slightly different behaviors, and they're both used to simplify code and make programming easier and more efficient, both for the programmer and anyone else who may need to look at their code in the future. Now, what's the difference between the two? Method overloading is an example of what they call a horizontal polymorphic behavior, and it is the requirement for it is that it's implemented within the same class and that the method signatures used for the two methods are different. Okay, what that means in Java is that you need to make sure that either the number, the type, or the order of the parameters in the different methods is different, and it does not include the return type of the method. So I've got one brief example here of overloading functions. And what I've done is in my main class I have declared two different methods, both of them called square, one of which takes an integer as the argument and the other one takes a double. So what they do is they compute the square of whatever argument you provide to them. One of them, taking the one that takes the integer, computes the square of the integer and returns that back to the main function. The other one, which takes the double, computes the square of that value and returns it as a double. So this would be a good example of overloading a method because we've got two methods that have the same name, they're in the same class, but their signatures are different. And once again, the way that a signature is defined in Java is by the number, the type, or the order of the parameters that you pass to that function. Inside the main function, I use system out println to call the two different square functions, and my output should be what you see here down at the bottom. Let's go ahead and test this real quick in Java. I'm gonna go ahead and copy the code, switch to my Java IDE, paste it, and then execute, hopefully getting down here an output similar to the one on my handout. So it compiled, it ran, and as you can see here, I did end up with the exact result that I was expecting. Now when you look at this, this example code uses the println function, which is yet another really good example of overloading functions in Java, because you may, with the println function, you may pass an integer to it, you may pass a double, you may pass a string, and it always works. It does not complain. Why? Because somebody already took the trouble of overloading this function so we could call it with different types of arguments. As a matter of fact, when you look at the list of arguments here, even the plus sign, the addition, is an overloaded argument because it works when you add two integers, it works when you add two strings, it works when you add a string to an integer or a string to a double. So these are perfect examples of overloading functions in Java. That said, overloading is mostly used for overloading constructors. But again, it's just a tool that is really useful for making your code simpler and easier to read and making your job easier and more efficient. Now, method overriding is an example of what they refer to as vertical polymorphic behavior, because what we need is different classes that have an is a type of relationship. Okay, so we're using inheritance here. We're going to have a superclass or a parent and a subclass or a child. And then the other requirement is that the methods that we're overriding have the exact same signatures, meaning that they'll have the same type, order, and number of parameters. Down here we have an example of method overriding. I have a superclass called vehicle, and I've got a function called run, which is implemented by simply displaying to the screen what it means for a vehicle to be running, and it simply prints vehicle is running. I got another class called bike, which is a subclass of the vehicle class. In other words, bike is a type of vehicle, and inside that class I override the run function or the run method to make it work slightly differently. So how does a bike run? I'm being more specific here. A bike is running safely, or you can actually change that and describe in some more detail what exactly it means for a bike to be running. Now, if this thing works, if I have successfully overridden the run function of the vehicle superclass, when I execute the main function, I create a new bike object, and then I call the run method on that bike object. I should see bike is running safely on the screen. Let's go ahead and test this. I'm going to copy the code, switch back to my Java IDE, paste it, click the run button, and keep an eye down here on the output window. Takes a few moments, and there it is. It says bike is running safely. So what I did here was I was able to successfully override the run function, and again notice that the signatures are identical. This is a requirement for overriding functions, and then I use that in the main class to test and make sure that it works. One more point here: with overriding, you're only allowed to override methods that have been inherited. In other words, they need to exist in both the superclass and the subclass, which are not private, static, or final. And you are not allowed to override constructors. If you recall, I did say overloading constructors was the main reason overloading existed. With overriding, you don't really want to do that. You only use overriding to override the functionality of methods that are not constructors and have not been declared as private, static, or final. So, just to recap real quick, the quickest and easiest way to remember the difference between these two, which are quite often confused, is that with method overloading, the overloading takes place within the same class, and the requirement is that the methods have different method signatures. With method overriding, the overriding takes place inside two different but related classes, and the method signatures are identical. Let's go ahead and take a few moments to do a couple of exercises and implement one example of method overloading and one example of method overriding, because muscle memory is important and it's the best way to learn a new concept. So let's go ahead and start with method overloading. Got one example here, which from what it does is it asks us to create a class called person that has two attributes, a first name and a last name, and it has three different versions of the constructor. So we should be able, once we're done, to create or instantiate this class by providing no arguments at all, in which case we simply set the first name and the last name to be just blank strings, by providing only one string, which we would assume would be the last name of the person, and we would set that appropriately. So we're going to set the last name attribute to be whatever that argument is, and we will set the first name to be just a blank string. And then finally, we'll also need to be able to set up a person object by providing both a first and a last name. Once we're done, we will be able to test and make sure that this works by using the print method, which simply displays on the screen my name is, along with the first name and the last name of that object. Alright, this is down here. We can see what the final output of this sample code should look like. So I would recommend that you pause the video at this point and take a few moments to try this on your own. When you're done, come back, unpause the video, and then we'll compare what you have with the way that I've implemented this. Okay, we're ready to continue then. I'm going to copy this part of the code, go back to my Java IDE, paste it, and I will replace all the to-do statements with the necessary code. So the first constructor, the first version of the constructor, takes no strings, and it sets the person object to have two blank attributes. How do we do that? We're going to use a keyword called this. I don't know if you're familiar with it, but what it does is it references the particular instance of the object of this class that's calling the constructor. So what I'm going to do here is I'm going to say this first name should be set to an empty string, and this object's last name should be set to an empty string. Okay, that pretty much takes care of the first version of the person constructor. Now the second one assumes you have provided a string for the last name, so I'm going to use that to be the value set for the last name of the person. Okay, and I will still set the first name to be just an empty string. So this is just one more version of the way we can construct a person object. Alright, now going down through the code, we have one final version to take care of, and this one takes two strings as the two arguments. So what that means is I'm going to use both of those to assign them to the right attributes, to the corresponding attributes. So first name for this object is going to be fname, and then the last name attribute will simply take the value of lname. Alright, let's take a quick look here. We have three different versions of the constructor, and the only other to do as you scroll down through the code is where we need to print the names. Now let's back up a couple of lines here. We can see that we have a print function, and so all we need to do is simply call the print function on these three objects, P1, P2, and P3, and then check and make sure that we end up with the right output. Alright, so P1 print, P2 print, and P3 print. Once I run this, I should end up with something similar to this. So the first person doesn't really have any names, the second one has only a last name, and the third one has a full name. Okay, I'm going to hit the run button here, keep an eye on the output window, and there it is. So this was an exercise in setting up an overloaded function, which just happens to be the constructor. And like I said earlier, it's the most popular reason people use overloading in higher level languages, and that is to overload the constructor. It's not the only one example, but it is one of the probably the most popular reason why you would consider using overloading. Alright, and that wraps up method overloading. Now let's go ahead and do a quick exercise in method overriding. And in this example here, we are creating a hierarchy of animals. The superclass, or the parent, is called the animal class. All we really need to do here is just implement a move method that describes what movement means for animals, and when we look down at the output, we can just set it up something like animals can move. Feel free to change that if you like. Now the dog class is in an extension of the animal class, so it inherits the properties of the animal class. What we're going to do is we're going to actually override the move method and provide a more descriptive or more accurate, more pertinent implementation for the move class as far as the move method as far as the dog class is concerned. Okay, we want to end up with something roughly looking like this. Dogs can walk and run. And then the main class has a main method which will test this. We will declare an animal object, we will declare a dog object, and then we're going to cause both of those to move, essentially ending up with something that looks like this on the screen. So once again, please pause the video here and take a few moments to see if you can write this on your own. When you come back, we will continue with my implementation of this. Alright, hello and welcome back again. Here's the way that I am going to implement or solve this exercise. I'm going to go ahead and copy all the code just to save a little bit of time. Come back to my Java editor, replace everything I already have here with the initial setup or initial skeleton for my little project, and let's start from the beginning. So we have here an animal class that needs a move method. Alright, I'm going to do a public void move. It doesn't really need to take any arguments. And what it's going to do is simply print system out print line animals can move, and that's pretty much it. This is what the move method for the animal class is supposed to do. It describes how animals move. Now the dog class, which is a child or subclass of the animal class, will automatically inherit the move function. But in this scenario here, what we want to do is we want to make sure we override it. And one of the requirements was we had to make sure that the method has the same name and the same signature. So I am going to get rid of the comment first. I'm going to type public void move and make sure that it doesn't take any arguments. And once again, I'm going to do system out print line the way the dogs move, again for the purposes of this exercise, would be we're going to say dogs can walk or run. So dogs can walk or run. So we have a new implementation of this move function. We're being more specific as to what exactly it means for a dog to be moving. We're missing the semicolon here, and that takes care of that. And now finally, in order for us to be able to test this, we're going to need to create an animal object and a dog object. So we're going to do animal and instantiate it with the default constructor. We have not provided any specific instructions on how to construct an animal object, so they should be good enough. We're also going to create a dog object and instantiate that. And then finally, we are going to test and make sure that our overridden method works properly by simply calling the move function on both the dog and the animal. So animal dot move and dog dot move. One final quick look. We have, it appears, all the functionality that we need. So I'm going to hit a run button, and if everything works properly, what we should see down in the output window is something similar to this. Okay. Oops, going back to our code. Hit the run button. Takes a few moments to compile and execute, and that is it right there. Animals can move and ducks can walk or run. So um, that solves the second exercise on method overriding and also wraps up our session. Thank you very much for watching. I hope you found this a useful video tutorial. If you encountered any problems, if you have any questions or comments, don't hesitate to send me an email. Kailin Dimitrov with an email at kailintro@yahoo.com. Thanks again.